So for this question, it says at the beginning of an experiment, a bacteria population is 6,000. The population triples every hour. Which expression represents the total population of the bacteria after 4 hours? So as usual, let's annotate. So at the beginning, the bacteria population is 6,000. Then the population triples every hour. So we want to find expression for total population after 4 hours. That's what we're focusing on. All right, so let's go. So as you have seen, I've modeled. The table is just a really, really good tool to use. In the top row of my table, I'll have number of hours and then the total population of the bacteria. As stated, we start out with 6,000 in the first hour. And that triples, 6,000 at the start, and that triples, which means we're multiplying by 3 after 1 hour. So 6,000 times 3 is going to give you 18,000. After 2 hours, that is tripled again, so we're multiplying by 3. That 18,000 becomes 54,000. And by the third hour, it triples again, so multiplying by 3 once more, that becomes 162,000. And by the fourth hour, it triples again, multiplying by 3 again, so that becomes 486,000. No, that's a total. They want the expression. What we're noticing is we start with 6,000 and we keep multiplying that by 3, the result by 3 each time. And repeated multiplication can be expressed using exponents. So what is being multiplied, what's a growth factor here, or constant growth factor, is 3. So that 3 is multiplied by itself 4 times, representing the fourth hour. So the expression that models this is going to be the first expression, which is 6,000 times 3 to the fourth. We couldn't use 6 plus 3 times 4, because 3 times 4 is 12, and that's 6,012. So we know that option 2 is wrong. If we're looking at this, 6,000 times 4 to the third, the growth factor is actually 3, not 4. So the 4 is not the base number. And in the fourth option, we're seeing 6,000 times 3, that's 1,800 times 4. No, that should be continued to be tripled, so it could also not be option 4. So our correct response is option 1, because our growth factor is, we have a constant growth factor of 3. So this is, yep, it would have to happen. Of 3, we know we're looking at exponential growth. Yay.